We're here, speeding from the summer solstice to the autumn equinox. The full moon rises to the east just as the sun sets in the west. Around midnight, you see it hasn't risen very high in the sky, while the midday sun still climbs very high at this time of year. In winter, the sun will pass low in the sky, as low as the full moon does in summer. Seen by an extraterrestrial, the moon is right opposite the sun, roughly on the same plane as the Earth and planets. Since the Earth's axis is tilted, here's what we see in summer. The sun appears high in the sky. At night, we look in this direction and the full moon seems low, near the horizon. By day, the sun is high in the sky, and at night, the full moon is low. In winter, it's the opposite. With the Earth here, its northern half pointed away from the sun. In winter, from this perspective, the sun passes low in the sky, and the full moon high up, each in turn. After climbing higher in the sky each day, the sun is beginning to move down again. If your windows look south, at noon today you'll see that the sun is still high in the sky. It shines on the floor near the window. Because in the summer, it's not the window that faces the sun, but the roof. Seen from space, it's like this. The sun shines on the roof. Then, as the Earth advances on its orbit, its northern half leans further and further away from the sun. It's the Earth's swinging motion that changes the angle of the sun's rays. In winter, sunlight falls at a shallower angle and shines further into the room. The sun will move down towards the horizon, crossing the sky on a lower and lower path. At the solstice, the midday sun was vertically over the 23rd parallel. At the autumn equinox, it will have moved down until it's directly over the equator. But before we get there, we still have more than 200 million kilometers to travel. We all know the Earth is round, but on holiday at the seaside, you can really see its curve. Standing at the water's edge, you look at the horizon, nothing gets in the way. You feel you can see forever. But you're wrong. Because of the Earth's curve, the horizon is only 5 kilometers away. You have a picnic on the cliffs, 10 meters above the sea. Now the horizon is 11 kilometers away. A ship appears on the horizon. You see its funnels first because the hull is hidden by the Earth's curve. The ship is 2 times 11 kilometers away. That's 22 kilometers. It's behind the horizon. As it approaches, it seems to emerge from the sea, climbing the hill, which is really the Earth's curve. When you climb a higher cliff, 100 meters high, the horizon you see is 35 kilometers away. In the mountains, you can see further. Mont Blanc is visible 200 kilometers away, and if you look at it from another mountain, that stretches your line of sight to 400 kilometers. Strangely, you can see only 5 kilometers at the edge of the sea. The empty but nearby horizon limits our view and so reveals the Earth's curve. Nearly a month after the longest day, the sun sets 10 minutes earlier. Why does the setting sun turn red? Well, the light of the sun is white, but what we see as white is really a mixture of all the colors of the rainbow, from violet to red. Light has to pass through the atmosphere before it reaches us. The atmosphere acts as a filter which absorbs part of the light, especially on the violet side, while the orange and red rays pass more easily. At noon, the sun's rays pass through only a thin layer of atmosphere. The filtering effect is weak, so the light stays white. In the evening, the sunlight arrives on a slant. At this angle, it has to pass through a thicker layer of atmosphere, and the filtering effect is stronger. All the colors are absorbed, except red. The lower the sun sinks, the more atmosphere its rays pass through, and the redder it looks. As the sun descends, it seems to distort and flatten. This, too, is because of the atmosphere, which not only filters colors but also bends light rays. The thickness of the atmosphere distorts the solar disk, squashing it into an oval. When the atmosphere is also disturbed by winds and heat, we see the sun torn apart. The sun sets 2 minutes earlier than the day before. But when you look at the setting sun, it's not really there anymore. It's already been under the horizon for 8 minutes. 8 minutes is the time light takes to cover the distance between the sun and the Earth. The particles which carry light travel at 300,000 kilometers a second. That's the ultimate speed. Nothing in the universe can move faster than light. We see light as something instantaneous. We even see distant lights just as they come on. In the solar system, the moon's light reaches us in 1 second. But the light of the stars in the constellation Orion takes centuries to get here. Imagine looking at Orion not from Earth, but from another part of the universe. Here you can see these stars are at very different distances from the Earth. You see them as they were a long time ago, centuries or millennia. When you look at the stars, you travel back in time. But you see the sun live. And now the solar system is within your reach.